Hello students, welcome to the maths class. Today in this video I am going to explain a new topic, matrices. It is very new topic for you students because till class 9th you did not study this topic. But it is easy topic. So one by one I will explain the points of this topic. Before that, in last video I completed chapter number 11 and I hope you also have completed the chapter in your notebook. So after 11th chapter you can take this 9th chapter, exercise 9th. Before starting the exercise I will tell you what is matrix. Order of a matrix means these 10 points I have written in front of you. These 10 points I will explain one by one. You try to understand each point. It is easy topic. Once again I am telling to you, it is easy topic. It is not a tough topic. If you listen carefully, if you try to understand carefully, then each and everything will be clear to you. Now first point is coming, matrix. What is a matrix? So students, a rectangular arrangement of numbers. A rectangular arrangement of numbers arranged in rows and columns is called a matrix. For example, 2, 3, 4, 5. It is a rectangular arrangement of numbers and these numbers should be enclosed by the square brackets, big brackets you can say, or by parentheses. By parentheses means round bracket also can be taken. In place of big brackets, round bracket also can be taken. So 2, 3, 4, 5. One example, 2, 3, 4, 5 I am taking. So this is a rectangular arrangement of numbers in rows and columns. What is a row? Row means horizontal line. 1, 2. Two horizontal lines are there. So these horizontal lines are called rows. Columns, vertical lines. Here in this matrix, two vertical lines you can see. 2 and 4 are in one vertical line, 3 and 5 are in second vertical line. So these vertical lines are called columns. 2 and 3 are in first horizontal line, 4 and 5 are in second horizontal line. So these two horizontal lines are called rows. So one more time I am telling to you, a rectangular arrangement of numbers arranged in rows and columns is called a matrix. So this matrix, like this also you can take matrix 2, 3, 4, 5, 9, 0. It is also a rectangular arrangement of numbers, and this rectangular arrangement of numbers I am telling to you again and again, you have to enclose this arrangement in within square brackets you can say, or big brackets you can say, or by round bracket also you can enclose, but don't use curly bracket. In curly bracket you cannot enclose these numbers. So this is also a matrix because it is also rectangular arrangement of numbers. Here 1, 2, two horizontal lines, it means two rows are there. 1, 2, 3, three vertical lines, it means three columns are there. I think you have understood what is a matrix. Now second point is coming, order of a matrix. What is the order of a matrix? One example I am taking. Suppose 2, 3, 4, 5, 6, 7. It is a matrix. Here number of rows you have to count. How many rows are there? Row I am denoting by capital R, column by C. So how many rows are there in this matrix? 1, 2 rows. How many columns are there? 1, 2, 3 columns. So if you write 2 and 3 here at the right corner, bottom right corner, 2 by 3. So number of rows first and then number of columns second. In between multiplication sign will come and it will be read as 2 by 3. 2 multiplied by 3 will be read as 2 by 3. So we can say order of this given matrix is 2 by 3. So you have to write number of rows first and multiplication sign and then number of column to the right bottom of the given matrix. So it will be order of a matrix. So suppose I take another example 1 2 3. This example I am taking in this matrix, it is also a rectangular arrangement. How many rows are there? 1 2 3 rows are there. So 3 multiplied by 1 column is there 2, sorry 1. So 3 multiplied by 1 you have to read as 3 by 1. Order of this matrix is 3 by 1. And where you have to write? You have to write at the right bottom, right side, yes, right bottom to the given matrix. So like this you can find the order of a matrix. Now notation of a matrix means how matrix are denoted. Any matrix you can denote by capital letters. A equals 2 3 1 9 like this. X equals 1 2 like this. B equals 2 like this you can take. It is also a matrix. Its order is 1 by 1 because here one row and one column is there. So its order is 1 by 1. So now notation means I was telling to you matrix are denoted by capital letters. Generally they are denoted by capital letters. Fourth point is coming types of matrices. Now this is important point. How many types of matrices are there? Very easy. You one time you listen carefully, you will understand what I am telling. Row matrix, a matrix in which only one row is there, that is called row matrix. Suppose 2 3 4, you can see here one row is there, so its order is 1 by 3. Column, how many columns may be there? 1 column, 2 column, 3 column, 4 column, 5 column, n columns. How many columns are there? No matter, but row should be only one, so that is called row matrix. So one row is there, so that's why it is row matrix. One more example you can take 2 3 4 5 like this you can take. So its order is 1 by 4. So row is one only, so that's why it is row matrix. In the same way column matrix, if one column is there 1 2 3, one column is there, 3 rows are there 1 2 3, 3 into 1, its order is 3 into 1, 1 2 3 rows and one column. So it is a column matrix. Square matrix, now next is coming square matrix in which number of rows and number of columns are equal, that is called square matrix. Just before I told you 2 3 4 5, here 2 rows 2 columns, order is 2 by 2, so it is a matrix of order 2, we can say it is a matrix of order 2, or you can say of order 2 by 2 also. And generally you can say for square matrix it is a matrix of order 2, it is a matrix of order 3 if it is 3 by 3 matrix, means in the given matrix 3 rows and 3 columns are there. So one more square matrix, this 2 1 by 1 order, it is also square matrix, 1 row 1 column. One more you can take 2 3 4 5, just before I told you 2 by 2 order. Now 2 3 4 5 0 9 1 1 2. So here you can see 3 rows 1 2 3 rows and 1 2 3 columns, so 3 by 3, it is also a square matrix of order 3. Now rectangular matrix, when square matrix, just before I told you number of rows equal to number of columns, so in rectangular matrix number of rows is not equal to number of columns, means 2 3 4 4 5 6, here you can see 1 2 rows 1 2 3 columns, so its order is 2 by 3, so it is a rectangular matrix. That column matrix and row matrix, yes, column and row matrix both are the rectangular matrices because number of rows is not equal to number of columns. Now zero or null matrix, what is zero matrix? In which every element is zero, that is zero matrix, or you can say in other words null matrix. 0 0, it is a zero matrix, or you can take 0 0 0 0 like this you can take, 0 0 like this you can take. These all are zero matrix of different orders because every element in these matrices is 0. Next, diagonal matrix. Diagonal matrix means a square matrix. Diagonal matrix means always a square matrix in which the elements on the principal diagonal, leaving the elements on the principal diagonal, other elements are 0. So that is called diagonal matrix. So 1 0 0 0 2 0 0 0 5. You can see it is a square matrix or not. First of all, you check. Just before I told you diagonal matrix means a square matrix. So yes, 1 2 3 rows, 1 2 3 rows and 1 2 3 columns. So it is a square matrix of order 3. Second thing, I told you leaving the elements on the principal diagonal, other elements must be 0. So you can see here, leaving the elements, this is the principal diagonal. Principal diagonal means the diagonal from top left to bottom right. So from top left to bottom right, this is the principal diagonal. You can see this diagonal is principal diagonal. So on this diagonal, leaving the elements on this diagonal, other elements should be 0. So you can see on this diagonal 1 2 3 elements are there, 1 2 3 1 2 5, sorry, and other elements are 0. So that's why it is a diagonal matrix. Next point is coming, unit or identity matrix. You can say unit matrix or identity matrix. It is a diagonal matrix, but a special type of diagonal matrix. So if it is a diagonal matrix, it means that on the principal diagonal elements will be there, other elements will be 0. Principal diagonal, just before I told you this diagonal. So on this, which type of element should be there so that it may become unit matrix. So unit should be there. Unit means 1. On the principal diagonal, if you take 1 and other element 0, then it will be a unit or identity matrix. So it is a diagonal matrix or not? Because leaving the elements on the principal diagonal, other elements are 0. So that's why I said a diagonal matrix, a special type of diagonal matrix is called unit matrix. What is the specialty? It is a diagonal matrix and on the principal diagonal elements are 1 only. Exactly 1 must be there. So that's why it is a unit matrix or identity matrix. Transpose of a matrix. What is the transpose of a matrix? Very easy point. Suppose that you are having 2, 3, 4, 5, 6, 7. One matrix you are having. If you interchange rows and columns, then it will become transpose of this matrix. Suppose this matrix is denoted by capital A. So its transpose will be denoted by A dash or AT or AT, like this you can take. So it will be written as you interchange rows and columns. So rows you make columns and columns you make rows. So 2 3 4 2 3 4 5 6 7. So now you have changed rows into columns or columns into rows. So this A dash is the transpose of given matrix A. I think you have understood what is the transpose. You have to interchange only rows and columns. Now you can see here order is 2 by 3, 2 rows and 3 columns. Here order is 3 by 2. Order will change. Just opposite order you will get after taking the transpose. Means of transpose matrix, order will be just opposite of the given matrix. If given matrix is of order 2 by 3, then it will be of order 3 by 2. If it is a given matrix is square matrix, then transpose order will be same. Suppose square matrix of order 2 by 2, then transpose will also be a matrix of order 2 by 2. Next, addition and subtraction of matrices. 7 point is addition and 8 point is subtraction of matrices. Addition, how means how can you add the matrices? First of all, I will tell you matrices can be added only when their orders are same. Suppose you are having one matrix 2 1 2 plus second matrix 2 3. Now you can see its order is 1 by 2, its order is also 1 by 2, 1 by 2 order. So both are the matrices of same order. So you can add. How can you add? You can add the corresponding elements. First element to first element, second element to second element. So 1 plus 2 3 and 2 plus 3 5, you can see. So like this, it is also a matrix of order of same order 1 by 2. Like this you can subtract. Suppose your subtraction sign is there, then how can you subtract? First of all, order should be same to subtract the matrices. So 1 minus 2 minus 1 and 2 minus 3 minus 1. So minus 1 minus 1 minus 1. It is also a matrix of order 1 by 2. So like this you can add and subtract. So what is the condition to add the matrices or to subtract the matrices? Order of the matrices to be added or subtracted should be same. Now next point is coming, additive identity and additive inverse. You know, in case of real numbers, what is the additive identity? If a number is added to 0, 0 plus 3, or 0 is added to a number 3 plus 0, then number is same always, means result is same, and that number which you are taking 0 plus 3, 3 plus 0 is equal to 3. So here we say that 0 is the additive identity, because by adding 0 to a number or by adding number to 0, number does not change. So that's why 0 is the additive identity. In the same way, 0 matrix is the additive identity in matrix algebra. 0 matrix is denoted by O, especially O, and identity matrix is denoted by capital I. I did not tell you, but I am telling to you now. 0 matrix or null matrix is denoted by O, and identity matrix is denoted by capital I. So by taking additive identity in matrix algebra, A plus O equals O plus A equals A, means if any matrix you add to 0 matrix, or if you add 0 matrix to any matrix, then matrix will be same. A plus O equals O plus A equals A. For example, if you want to take example 1 2 plus 0 0 equals 1 plus 0 1, 2 plus 0 2. So matrix is same or not? So like this you can take 0 first, means null matrix first, and this given matrix at second place, then also 1 2 you will get. So 0 matrix is the additive identity. Now additive inverse. In case of numbers, you know, if 3 you are adding in 3, what should be added in 3 so that it becomes 0, means additive identity you will get. So minus 3 you will have to add, then you will get only additive identity 0. For every number, suppose you are taking minus 5, so what should be added in minus 5 so that you can get additive identity 0? Plus 5 you will have to add, so then 0 you will get. So in the same way, identity matrix is the, sorry, not identity matrix. In the same way, suppose as in case of number 3 minus 3, so 3 is the additive inverse of minus 3, minus 3 is the additive inverse of 3. In the same way, in matrix A and minus A, suppose one matrix A is given, so its negative will be its additive inverse. When you add one matrix and its negative, then you will get 0 matrix. For example, you can take 1 2 3 4, then plus minus 1 minus 2 minus 3 minus 4. When you add both the matrices, then what will you get? 1 minus 1 0 0 0 0, null matrix you are getting. So just before I told you, as in case of numbers, for 3 additive inverse is minus 3, for minus 5 additive inverse is 5. In the same way, for matrices, for A, for given matrix A, additive inverse is minus A. So negative of the given matrix you will take as additive inverse. Now after this, these were the points, and I hope You have understood all the points. Now I'm going to take some examples. You see first example. Find the values of x, y, a and b if these two matrices are equal. Equality of matrices. When two matrices will be equal? When suppose that two matrices are equal, then their order will be same. Must be same. Two matrices may be equal if they are of same order and their corresponding elements are same. Means first element is matching with first element. Suppose a and b two matrices are there and suppose they are saying they are equal, so it means that a will be equal to b when order of these two matrices are same. Suppose it is of order m by 2 by 1, it should also be 2 by 1 order and their corresponding elements are also same. Means first element to first element, second element to second element, they should match. So now here in the example you will understand more clearly. You can see here two matrices are equal. So first of all you can see the order. It is of order 2 by 2. First matrix, second matrix is of order 2 by 2. So orders are matching, so they may be equal. Second thing, corresponding elements are same. First element is equal to first element of other matrix. X minus 2 is equal to 0, y is equal to 3, you can see, and a by 2 is equal to 1, you can see, b plus 1 is equal to 5, you can see. So x minus 2 equals 0 means x equals 2, y equals 3 you have found directly. A by 2 equals 1 means a equals 2, b plus 1 equals 5 means b equals 4. So you have found like this the values of x, y, z, sorry x, y, a and b. So this was the equality of matrices. Next point is addition of matrices. Here some examples you can see for addition. These are the examples. A is given, B is given, C is given. You have to find A plus B and B plus A. A plus B, first matrix plus second matrix. First element to first element, 5 plus minus 3. 5 minus 3, 2. You can see here. 4 plus 0, you can see 4 plus 0, 4. 3 plus 1, here 3 plus 1, 4. Minus 2 plus 4, minus 2 plus 4 plus 2. So like this you can add. Now next B plus A. B plus A, 3 plus 5, minus 3 plus 5, you can see minus 3 plus 5, 0 plus 4, 0 plus 4, 1 plus 3, 1 plus 3, 4 plus minus 2, 4 minus 2. So now minus 3 plus 5, 2, 0 plus 4, 4, 1 plus 3, 4, 4 minus 2, 2. So in both the cases A plus B equals B plus A. Both the cases you can see A plus B was coming 2 4 4 2, 2 4 4 2, B plus A also and A plus B also. There are, you can see here this one and this one, they are matching. It means that A plus B is equal to B plus A. So matrix, addition of matrix is commutative. Addition is commutative in matrix algebra. Next point is coming A plus B 2 4, A plus B plus C you have to find. So A plus B you have found 2 4 4 2 and C is given. Now you add 2 plus 1 3, you can see here, 4 minus 3 1, 4 plus 0 4 and 2 plus 2 4. So you have found A plus B plus C. Now you have to find A plus B plus C. So first you find B plus C. So B plus C, because B plus C is given in bracket. So B plus C first you find, B and C, minus 3 plus 1 minus 2, 0 plus minus 3 minus 3, 1 plus 0 1 and 4 plus 2 6. Now in this B plus C you add A plus B plus C, 5 minus 2 3, 4 minus 3 1, 3 plus 1 4 and minus 2 plus 6 4. So in both the cases you can see here this answer and this answer. When you are adding A and B together and then you are adding C, or when you are adding B and C together then you are adding A, then in both the cases answer is same. So it means that this addition is associative also. So you can see here A plus B equals B plus A and A plus B plus C equals A plus B plus C. So addition of matrices is commutative, addition of matrices is associative. Next example is coming. Here you can do this example yourself. A plus C you have to find, B minus A plus B minus C you have to find. So here third part you can see only A plus B minus C, A plus B minus C. So first thing you do, A plus B, first you add these first two matrices. 5 plus 2 3, sorry 5 plus 2 7, 4 plus 1 5, 3 plus 0 3, minus 1 plus 4 3. Now you subtract this matrix. So how to subtract? 7 minus 3, 7 plus 3 it will become 5 minus 2, second minus second element, 3 minus 1 and 3 minus 0. So it is coming 7 plus 3 10, 5 minus 2 3, 3 minus 1 2, 3 minus 0 3. So like this you can subtract. Now one more example is coming. You can see matrix A is given, matrix B is given. Find transpose AT or A dash and B dash. If possible, then find A plus AT and B plus BT, B dash you can say. So A dash, you can find transpose. A matrix is given, you convert rows into columns, columns into rows. So AT equals 2 1 3, A dash equals 2 1 3, 4 minus 3 2. This row you have made column, this row second column. In the same way for B dash, first row first column, second row second column you have converted. So you have found like this transpose. After this addition is possible or not? A plus A dash is not possible. Reason, what is the reason? Because matrix A of order, it was of order 2 by 3, 2 rows and 3 columns, and A dash of order 3 by 2. You can see 3 rows and 2 columns. So orders are different. So you cannot add. Because I told you, then what is the condition for addition and subtraction? Order should be same. Orders of the matrices to be added should be same. In the same way, B plus B dash, it is possible. Why it is possible? Because B is the square matrix and its transpose is also a square matrix. So they can be added. They are adding 3 plus 3 6, minus 2 plus 7 5, 7 minus 2 5, 4 plus 4 8. So like this you can add. After this, matrix equation is coming. How can you solve matrix equation? What is matrix equation? You can see two matrices are given, A and B. Okay, matrix X you have to find. Here you can see A plus X equals B. It is the given condition or equation. A matrix A plus matrix X equals matrix B. So this is the matrix equation. In this, with the help of this matrix equation, you have to find this matrix X. So X will be B minus A. X will be B minus A. So B value you can put, X value you can put, and you can subtract. Minus 3 minus 8. Minus 3 minus 8 minus 11. 5 minus 6. Minus 1 because this minus is going on. 1 minus minus 2. 1 plus 2. 3. 0 minus 4. So minus 4. So you are subtracting, and then this minus 11, 3 minus 1 minus 4. This is matrix X. In the same way, in second part you can see matrix X will be A plus B. When you transfer B to RHS, then it will become positive. A plus B. So A plus B you are adding. So final answer is coming 5 minus 1, 11, 4. So this is the matrix X. So like this, all the questions you are going to get in exercise 9th. Again I am telling, it is very easy topic. Very easy topic. One time you listen this video, try to understand each point, and I think I explained each point in a very good way so that you can understand well. So after getting this video, you will be able to solve all the questions of exercise 9th. After that also, if you have any doubt, then you can ask in comment. I will clear your doubts. So thank you and have a nice day.